Welcome to this explainer. Today, we're peeling back the layers of modern artificial intelligence to look at the high-performance architecture running the enterprise backend. We hear so much hype, right? But we're going to uncover the actual software infrastructure that makes large-scale AI tools, apps, and websites possible. Let's just dive right in.
So look, Python is universally recognized as the face of AI. Everyone knows it, and it's absolutely fantastic for prototyping. But you have to ask yourself, what is the actual engine? What language powers the massive data streams when these models finally go into production? Because taking a brilliant prototype and deploying it to millions of users, that takes a completely different kind of engineering muscle.
Our explainer today maps out this whole hidden infrastructure. We'll quickly run through the engine behind AI, compare Python and Scala, and look at the Scala AI ecosystem. Then, we're going to get into building full-stack AI apps, look at a really fascinating AI coding advantage, and finish up with designing for the future. Starting off with Section 1, the engine behind AI.
Let's look at the core blueprint of Scala. It runs on the Java Virtual Machine, or JVM, and what it does is seamlessly blend object-oriented and functional programming. And this is huge because it focuses heavily on immutability and statelessness. When you're dealing with distributed computing, literally running a program across hundreds of machines simultaneously, immutability is your absolute best friend. It completely prevents those nightmare scenarios where data gets corrupted just because two machines tried to change it at the exact same time.
Now, looking at Python versus Scala. Python's dynamic typing and simplicity are great for figuring out what you want to build. But when you move to permanent, mission-critical systems, Python hits this wall called the global interpreter lock, which severely bottlenecks multi-threaded tasks. Scala, on the other hand, brings strict, static typing, robust multi-threading, and compiled execution to the table. Basically, Python helps you explore, but Scala is how you build a system so it never, ever falls down. Moving to Section 2, let's really dig into this Python versus Scala comparison, specifically when it comes to handling big scale. When processing extremely large data sets, Scala can literally execute operations up to 10 times faster than Python. 10 times. To put that in perspective, imagine an enterprise data pipeline that normally takes 10 hours to run in Python. In Scala, you're finishing that exact same workload in just 1 hour. When you're dealing with petabytes of data, that isn't just some minor technical detail. That is a massive reduction in operational costs, and it means you can deliver real-time AI insights instead of yesterday's news. Take a standard ETL pipeline, extract, transform, load. Because foundational frameworks like Apache Spark were actually written in Scala, using Scala for your pipelines gives you this incredibly seamless experience. You extract massive datasets using Spark data frames, apply functional, immutable transformations with total type safety, and securely load it to something like Delta Lake. It's fast, it's clean, and it's built to handle whatever the enterprise throws at it. All right, Section 3. The Scala AI ecosystem. It's not just about raw data processing. Scala actually has a deeply specialized ecosystem tailored for large-scale artificial intelligence. You've got Deeplearning4j for distributed deep learning with native GPU acceleration, Spark's MLlib for scalable algorithms, and tools like DataVec and Breeze for heavy numerical processing. You don't even have to leave the JVM. You can import models from TensorFlow and just run them natively. What we're seeing here is a major shift. We're moving away from throwaway data exploration scripts and really leveraging Scala to build permanent, scalable machine learning applications. It's essentially the difference between sketching out a rough draft on a napkin and engineering a load-bearing skyscraper. Which brings us to Section 4, full-stack AI applications. This is where it gets really cool. Scala isn't just for backend data pipelines anymore. It's increasingly being used as the primary software to build the actual AI tools, websites, and apps serving these models. Recent ML platforms are using a unified Scala monolith to avoid all that microservice complexity. They're using Scala for both the front-end interfaces and the back-end logic, packaged seamlessly with the mill build system. You even get hot reloading right in the browser for super fast iteration. So you skip the chaos of managing a dozen different microservices, but you keep that immense back-end power. Section 5, the AI-assisted coding advantage. This might be the most fascinating paradigm shift yet. Let's talk about how Scala interacts with AI code assistants. Look at this quote. Every @autowired, getter, and setter is a microtransaction against an AI's working memory.
Unlike Java, which forces an AI to burn through its token limit reading endless boilerplate, Scala's logic is compressed incredibly densely. Because of this density, a large language model can hold 3 to 4 times more of your code base in its working memory at once. It can actually reason across entire service boundaries. Think about it. An AI can fit a massive Scala project into its context window in a way it simply couldn't with the verbose language. It sees the upstream caller, the downstream effect, and everything tying them together. That is a massive architectural advantage for generating accurate functional code.
And when the AI does generate code, the Scala compiler steps in. As the quote here says, the compiler is the most disciplined code reviewer your team has ever had. It doesn't get tired. It doesn't just skim a pull request because it's late on a Friday afternoon. It strictly enforces every single rule.
In Scala, type defect systems essentially act as exact, rigid specifications for the AI. If an AI agent hallucinates or makes a type violation, the compiler instantly rejects it before a human ever even sees it. It creates this immediate, automated feedback loop that corrects the AI on the fly. You eliminate the ambiguity, and developers only end up reviewing code that actually makes structural sense.
Finally, Section 6, Designing for the Future.
People sometimes talk about the upfront complexity of learning Scala, but that's actually a profound architectural advantage for the future. Whether we're processing massive IoT data streams, evolving distributed training for large-scale models, or supporting next-gen enterprise SaaS AI deployments, even integrating with emerging quantum computing frameworks, Scala provides the high performance and strict reliability that these complex systems demand.
So, I want to leave you with a question as you look at your own enterprise architecture. With the inevitable rise of AI coding agents, are you optimizing your code base for the median human developer, or are you preparing it for the AI that's going to be reading it tomorrow? It's definitely something to think about. Thank you so much for joining me for this explainer today, and keep exploring.